Hi everyone, my name is Thomas Kim. Today is May 10th, 2022. This is 106th episode of CUDA SQL OpenGL OpenCL MFC video series. This is also CUDA OpenGL tutorial 32nd episode. In this episode, I will discuss symmetric difference quotient, also how to determine polynomial. For more information about the symmetric difference quotient, please double-click this link. In this episode, we will use this equation for numerical differentiation. Actually, I don't like this formula, but this formula is very simple to implement. In future episode, I will use 5-point stencil algorithm. To follow my current session, please visit episode 106, CUDA OpenGL tutorial 31. Please double-click this link. Because my current session continues from our previous episode. If you haven't watched my previous video, episode 106, please watch it. Otherwise, you may not be able to follow my current and future sessions. Click More. If you scroll down, you can find source code download section, episode 106. Please click this link to download source code from our previous episode. Show in folder, unzip it, rename the folder 107 Symmetric Derivative. Copy the folder path, paste it in your working directory. Now start Visual Studio Code. Open your working folder, Symmetric, OpenGL, OpenCL. In the Explorer, select folder 107, Symmetric Derivative. Click this button, symmetric.cpp. Hit Enter, Ctrl B. Please understand that I will be using C++23 standard. If C++23 comparable C++ compiler is not installed on your machine, you may not be able to follow my current and future sessions. Include CPG, SCD extension, include numbers, include CMS. Ctrl-Shift-P, edit configuration JSON. From now on, we will be using C++23 standard. Now change your focus, then you can close this file. enum class polynomial failed const fun polynomial non-polynomial. I would just say non-poly. Contextful auto by std numbers 5 std ostream operator std ostream os polynomial. I made a typo here. Polynomial. Const L-value reference P. Using enum polynomial. This declaration is supported since C++23 standard. Switch P case constant fun OS constant fun return OS case polynomial OS polynomial return OS case non-poly OS non-poly return OS default OS failed return OS. We can also say case failed. So we overloaded operator for class polynomial. We will test this function. Void test polynomial. Int main, copy this function name, copy, paste it here, std, cout, polynomial, const fun, polynomial, const fun, std, enter. Now start your command prompt, cd 107 symmetric derivative G++ version. I'm using latest version of GNU G++ version 11.2. Also Clang, I'm using Clang version 14. G++ std C++ 2b symmetric.cpp ltbb or g.exe. It built successfully. I will copy this command prompt, Control Home, paste it here, clsg. So it is displayed properly as a string. Let's try with the Clang compiler. Clang clsc. Clang compiler also works. Now we will create symmetric derivative function. I will paste two links for your reference. If you want to follow my videos, then you need this library. If you haven't installed C++ library extension, you may not be able to follow my video sessions. Also, for symmetric difference quotient, please control-click this link. We'll be using this expression in current episode. Actually, I don't like this expression, but it is easy to implement. In the future sessions, we'll be using 5-point stencil derivative algorithm. Here, template, type name, fun type, type name, arg type, concept, callable 1c std is invocable rb arg type. This is return type. Callable type is fun type. Then comes arg type. We defined a concept. Here, template, type name, fun type, type name, arg type, type name, delta type. I will set it double. Requires, we are using constraint. Callable 1c, we pass fun type here, then arg type. Return type will be arg type derivative symmetric. The first comes fun type f, arg type x, int n1, then comes delta type h 0.1. If n0, return fx. Else if n equal 1, return fx plus h minus fx minus h over 2.0 times h. Else, please understand that I got this expression from this document. So basically I'm using this expression, or f1 derivative symmetric fx minus h n minus 1 h. Copy, paste. This is f2 plus h, return f2 minus f1 over 2.0 times h. Here again, I'm using symmetric derivative here. This function is recursive. We are calling derivative symmetric recursively when n is greater than 1. I will fix the typo here. Now, let's test this function. Void test derivative symmetric. Scroll down, copy this function name, copy, paste it here, disable this, or f1 double x, return std sin x, or f2 double x, semicolon, return x plus 2 times x minus 3 times x plus 5 times x minus 4. This is simple polynomial function of order 4. Int order 10 for int n 0 n less than order plus plus n, or s equals derivative symmetric f1. We pass pi over 4.0 and we will pass like this, std cout s n s, std, and there. I will copy, paste. Now this is f2 p p p, std cout std, and there. So we are calling test derivative symmetric this function. In this function, we define f1, f2, then we call derivative symmetric. We build again CLS-C. So these are derivative. Please note that in this case, this is polynomial function. See, f2, this is polynomial function. When p is 4, fourth derivative is 24, fifth derivative is very small number, almost equal to 0. We'll be using this property to tell if a function is polynomial or not. Control Home. I will introduce one more constant, context per, or exp e, std numbers e, control end. Here, template, type name, func type, type name, arg, type. I will set it double. Type name, delta type. I will set it with a double. Requires callable 1c. We pass func type, arg type. Return type is auto, is polynomial base. Func type f, arg type x equal 1.0 int try count. I will set it 11. Delta type delta x 0.1. I will give a carriage return here. Delta type delta y 1e negative 6. Here using enum polynomial int n 0 for n less than try count plus n or t symmetric derivative f x n delta x. If std abs d less than delta y break. If n equals try count, return std tuple polynomial int non poly n. I will change like this. Copy this, paste it here. This is return type. Now else I will unindent. If n equal 1, return const from n. Else return polynomial n. I will also fix this part like this. Or this is correct. Now here we create another function template type name func type name arg type. I will set it with double. Requires callable 1c func type arg type std tuple polynomial int is polynomial func type f arg type x 1.0 arg type delta x 0.1 delta y 1e negative 6 int try count 11 or p1 is polynomial base f x try count delta x delta y. I will call another one p2 x plus exp e. If p1 not equal to p2, return failed. I will declare using enum polynomial. Also here we declared polynomial. Also std get 1 p1 else return p1. Now let's build. We built successfully. void test polynomial. I will copy this function, paste it here. Test tell polynomial. Copy this function name, paste it here. Fix our code like this. Scroll up. I will copy this. Copy. Paste it here. Auto F3 $x semicolon return exp e constant function polynomial non-polynomial. Here auto poly order is polynomial f1. I will say f1 copy paste f2 f3 std cout poly f1 order f1 std enter copy paste poly f2 poly f3 Sorry, I made a simple mistake here. In the function is poly base, I made a simple mistake. Delete this function. Derivative symmetric. Scroll down. I also made a mistake here. -1 because we incremented n here. We have to subtract -1. Now I will remove some blank space. We are testing if this function is polynomial. If this function is polynomial, or if this function is polynomial. In the command prompt, we rebuild clsc. As you can see, function f1 is non-polynomial function. Function f2 is polynomial function order 4. 1, 2, 3, 4. Polynomial function of order 4. In case poly f3, it is constant function. This is constant function. So, is polynomial, this function returns if this f1 or f2 or f3 is either non-polynomial or polynomial or constant function. In this case, we used derivative symmetric. We will implement this algorithm using CUDA or SQL in near future session.